Hey guys, Math 1500, again, summer 2015. I know I'm going to regret saying that on every video because I'm going to want to reuse these for future classes, and it's not always going to be summer 2015, is it? I want to go over something that came up in the first video, I think, of this week. And, let's say that we have the following numbers. So 1, 2, 3, 4, 5, 6, 7. So we have we have 8 numbers here, okay, ranging from 50 to 100. And if we wanted to find the mean and the median and standard deviation, the easiest thing to do would put these in our calculator or input those into R. And I want to demonstrate both of those. But let's go through calculating the median and Q1 and Q3 by hand. And the reason I want to do this is just give you a better indication, give more of an understanding of where these values come from. All right, now if we take these in, I will count in. So we come in 2, and we come in 3, and we come in 73 and 82. We can see that there isn't a number that's distinctly in the center. So what we do when we have that is we're going to average the two numbers in the center. And I'm pretty sure that's going to be, let me just go ahead. I don't trust my arithmetic skills anymore. I don't know why. 77.5. So somewhere right in the middle of this, 77.5 is going to be the median. Now, the reason I want to point this out is in calculating the quartile, what do? Do we just include the numbers below, in which case Q1 would be equal to the average of 51 and 61? And look at the numbers above the median, starting with 77.5 is the median, then 82, 91, 97. So we would average these two, which would give us a Q3 equal to 94? All right. So keep in mind the median of 77.5, Q1 56, and Q3 94. So you might just want to just jot that down. Now, guys, if we want to do this on our calculator, we should be really good at this now. We've done it whopping twice. So I'm being facetious. Clear, enter. So let's type our numbers in. They don't have to be in order, but they can be. So 50, 51, 61, 73, 82, 91, 97, and 100. Now, I'll go back up. We know that we need 8 numbers, and we can see that the 8 here, so, life is good. So let's go to Stat. Let's go over to Calc. One variable stats. L1 is where we put our information. That won't always be the case, but it is in this situation. Frequency list, nothing, and we come down to Calculate. Now, when we scroll on down, we're going to see that our values for the mean and the median match up to what we got, what we did by hand. So that's good, right? That's the kind of stuff that we like when we take an intuitive approach, and the technology validates that. Now, let's bring up R. I should have already had this up. Let me find it. And in R, what I would do here is I'm just going to call my data something, and in this case, I'm just going to call it capital X. And I have to use my C function to take numbers and store them. So I'm going to take 50, comma, 51. There doesn't have to be spaces unless you want there to be. 73, 82, 91, 97, 100. So to make sure that we've got all of our numbers, I would just do length because that gives me my sample size. So I have 8 numbers. It doesn't tell me that the numbers have been typed in correctly, but at least I know I have the correct number of numbers. Okay. So guys, I can go median of X, and I see I get 77.5. And in the previous video, not the previous video, but the 2 videos before, I told you that we could take Quartile and find the Q1 and Q3. Now, when I do that, you're going to see that the quantiles, the first quartile, these numbers right here tell you the percentage of scores below. And notice that our first quartile is 58.5 and our third quartile is 92.5. Our median is still correct. It's 77.5, but R looked like it went kind of wacky for the 58.5 calculation, and it did go kind of wacky. Now, what I want to do is I want to show you something. If we do quantile X and go type equal 1, notice what will happen here is we even get a different Q1 and Q3. Statistics isn't complicated enough. It even gives us a different quartile. So what it does right here, the way that it's using type 1, and let me even show you even more craziness. If we go type equals 0, actually that's going to give us what we just had. Yeah, so if we leave the default, or if we have type 1 or type, let me make sure. I'm pretty sure that type 2, I've kind of messed around with this before. This is going to give us the same thing as we got. Okay, yeah, okay. Now, notice when we go quantile X type 2, notice that our values 56, 94, and 77.5 actually match up to what the calculator gives us. So, guys, I'm not doing this to confuse you because there's really no sense of, there should be no confusion here. There's just different ways to calculate your quartiles depending on whether or not you include the median. Do you just include the numbers below the median, or do you include the median and calculate the quartiles that way? So, long story short, from here on out, to be consistent with the TI-84 calculator, let's do quantile X type equal 2 when we want to report the Q1 and the Q3. And again, Q1 will be at the 25% mark, and Q3 will be at the 75% mark. Okay. Now, something I want to do now is I want to demonstrate something on R. A few years ago, we only used the graphing calculator to analyze data. And Dr. Kaser, who's the chair of the social sciences, and we have a lot of students in social sciences, and even some of the faculty from the nursing kind of chimed in, and they're like, we would like our students to learn a statistical software package other than the graphing calculator. Because when you get out there and get your job and you actually find yourself in a situation where you're going to have to analyze data, and you might say, well, what do you mean when? Guys, trust me, it's going to happen. We have become a crazy society today. No, not crazy. I think it's good. We've become a society today where we want data-driven decisions. And when you come to college and try to get a college degree and maybe go and get your master's or maybe even your PhD, we're preparing you for upper level positions. So upper level positions have to be accountable. They have to have, again, data to support decisions. Data-driven decisions is a buzzword that's floating around in management efficiency conversations today. So you will be doing some statistics unless you luck up and hit the lottery and don't have to work. But if you get into an upper level administrative or managerial position, you're going to be doing statistics. You're going to be crunching data somewhere along the line. So when you do that, it's going to be customary for you to do with a statistical software package. So the statistical software package we used to use was SPSS. We had a license at Shawnee State for somewhere around, I think it ultimately tapped out around $5,000. And then IBM bought out SPSS, and our license went from $5,000 to about $25,000. Well, in the times of budget crunches, our administrators wanted to find something that was more cost effective. And the student version of SPSS is about $100, and we didn't think it was fair to ask students to buy a book, access to a either Hawks or My Math Lab, and buy a statistical software package on top of that. So what we did is Dr. Dave Todd, who was the provost at the time, contacted me and said, Doug, we're going to start using R. Learn how to do it and train your fellow faculty members. So I learned how to do this. So let me show you. I'm going to close R down because I want to start with a blank slate. Now I want to show you what I've got. I have body fat here. Okay, it's already open. I have body fat saved on. Let's get this thing full screen. I've got this saved on my desktop. And you'll notice that we have a subject number, we have a tricep measurement, a thigh measurement, a mid-arm measurement, and a body fat. And let's say that I would like to get this information into R where I can analyze the data. Well, the first thing I want to do is I want to do a save as. I want to call it something, and I want it to be one word, no spaces. And I want it to be something relevant to the data set. Sometimes people just call it data, and I'm okay with that. But I'm going to call this body fat. And guys, again, I don't want any spaces there. I want just one word, not too many letters, 7 or 8, 3 or 4. Not something like supercalifragilisticexpialidocious. But I want something relevant and not many letters. The next thing I want you to do is I want you to save that to your desktop. And the next thing I want you to do is find the .csv. Now guys, this is where it gets confusing because there are multiple .csv formats that you can choose from. Do not choose MS-DOS. Do not choose Windows, separated. Come up somewhere. It depends on it depends on your computer. It depends on your statistical. I'm sorry, the Word documents that you have, or the Word programs. Come up and find where it just says separated values. Guys, if you want to drive yourself crazy and not be able to pull this off successfully, then choose MS-DOS. It's not going to work. Don't choose Windows, separated value. It's not going to work. I know students. I've taught this too many times before. Students will say, Dr. Darber, I can't get this thing to work. Well, you chose the wrong one. And you caused yourself a lot of headaches because you didn't choose the correct one. Guys, choose the one that says separated values.csv. When you do that, save it to your desktop. It's important you save it to your desktop because when we get into R, I'm going to show you how to manipulate R to go to your desktop to look for the data file that we want to open up. Okay, so I'm going to hit save, and it's going to tell me that it's already there. And again, I'm just demonstrating this. Now, it's going to come up and make you feel like an idiot and tell you that everything's selected wrong and blah, blah, blah. Go ahead and hit continue and don't worry about it. So, gang, what I now have on my desktop, as you can see, along with some other stuff, is I have a data set called body fat, and it's in a dot .csv format. Okay. Now what I want to do is I want to go into R, and I want to make R see that data set on my desktop. So what I want to do, it's called my working directory. And the default for the working directory for R is not your desktop. You have to make it be your desktop. So what I'm going to do first is I am going to do what's called get my working directory and see where R is currently going naturally to look for data sets. And it's just looking at users DDarbroom. So I know that's the format that I want to use to set my working directory to the desktop. Okay, so I'm going to go set my working directory. Guys, this has to be in quotes. It has to be the form that I used when it had get my working directory, but I want to set it to my desktop. Hit enter, and if you don't get an error or something of that nature, then you've done it correctly. So notice that I didn't get cool, thumbs up, nothing like that. Trust me, when you don't get an error, it's good. It means that it executed the command as it should have. Okay, now our June 10th meeting, that's going to be one of those things that if you're having problems with stuff like this, bring your your laptop in. I'm going to help you. The June 10th meeting is all about just getting together and addressing issues. I know some of you are having issues with Hawks. And I'll be honest with you, right now I'm not liking Hawks too well. I wish I'd stuck with my stat lab. But they tell me it gets better. They tell me that the first couple of chapters, that I don't know, it just doesn't seem as seamless. But they tell me as I get into later chapters, it's going to work more seamlessly. So let's keep our fingers crossed on that one. Guys, the next thing I'm going to want to do is I'm going to want to read my my file. So I'm just going to call this something. I'm going to not be real creative. I'm just going to call it data. And I'm going to use what's called a read.csv command through R. That's going to go to the working directory that I set, and the CSV file that I tell it to read, it's going to do so. So I want it to read, because again, this has to be in parentheses or in quotations. So I want it to read body fat. This is the reason I don't like a lot of spaces and stuff, and I like to keep it simple, because if you put a lot of spaces in there, it can make typing that exactly the way it's typed on your desktop to be problematic. I don't want that. I want to keep things simple. Statistics is hard enough without having problems accessing your data set. Okay? Now, once I get that, I can type data, and I can see that I've got my data set imported from the CSV file on my desktop. Okay? Now, I would like to be able to find the mean of body fat. So I say, well, I'll just type mean of body fat, because I have a variable right here called body fat, and I'd like to find the mean of it. Now, guys, this isn't going to work. It's going to give me an error and tell me that the object body fat wasn't found. Now, what's happening is I have imported the data set into R, but R hasn't recognized it yet. It'll look at it, but it hasn't recognized it in terms of performing any statistical stuff. So what I have to do, I'm sorry, it's not body fat, I called it data, didn't I? I have to attach my data. So when I do this read.csv, it takes this body fat file that's on my desktop, it brings it into R, and it calls it data. Okay? So I'm going to attach data. And now when I go to find the mean of body fat, I'm going to get to 20.20 like I did before. I'm going to get the body fat like I did, or I'm sorry, the standard deviation like I did before. Yeah. I'm going to get the variance like I did before. I'm going to get the median like I did before. I'm sorry. I don't think I got the same IQR, did I? 7.23. I think that was actually off a little bit. I don't remember. We'll have to go back and look at our notes. But I'll show you how to take care of that. Define the range. Remember, we have to subtract the two numbers it gives us. It doesn't calculate it for us. I wish it did, but it doesn't. I don't know why it doesn't. So the range is 15.5. Now, when it comes to the quartiles, what did we learn earlier? We want to find quantile of my variable, which is body fat. But I want my type to be equal to 2. And now the values should line up with what we had in the previous. Let me just see what type equal 1 and what it actually does. Wow, it really throws that off, doesn't it? Yeah, I don't remember what our values were. Which one actually lines up? Well, I don't have that data. I took that data out. So guys, again, when reporting, use the quantile type equal 2. So our IQR would be 24.65. Minus the 16.30. So 8.35 is our IQR. So again, guys, use this type equal 2 to be consistent with the TI-84 calculator. Next thing we did is we did a histogram. So if I want to do a histogram of body fat, works nicely, pops up. You'll see it gives you a different type of histogram because they use 1, 2, 3, 4, 5, 6, 7, 8, 9 bars instead of 7 or 8 like the calculator does. That's fine. That's okay. It has its own internal structure on how it creates the number of classes on a histogram. But still, we've got something that's bell-shaped and symmetric, so that didn't change. Something else we'd want to do is a box plot. And we get a box plot, and notice we don't have outliers, just like before. Now, we may not want to focus on body fat. Maybe we want to take a look at the triceps. So we can do the same kind of thing for triceps. We can find the mean of triceps. We can find the median of triceps. We can find the quartiles of triceps. We can find the standard deviation of triceps. We can find the variance of triceps. We can find the IQR of triceps. We can find a histogram of triceps. Now that has kind of a negatively skewed to it, so it's not bell-shaped and symmetric. This would be negatively skewed. And we can do a box plot of triceps. And still we have no outlier. Now, eventually what I'll allow you to do, or I'll teach you how to do, is maybe we've got this information across gender. Maybe we have another variable here that's gender of males and females. So we're going to be able to look at side-by-side box plots to examine comparisons across categories. But that'll be coming up in a future video. All right? All right, gang, let's say that we have an extremely large data set and we have what's called a frequency distribution summary. And this happens a lot when you have, lost my ink pen here. It happens a lot when we have large data sets with a lot of repeated measures. Now, something that would be a lot of repeated measures would be maybe age of students at Shawnee State, because we're going to have a lot of students who are 18, a lot of students who are 19, a lot of students who are 20, probably not so many that are 42. But we're going to have a lot of ages where we have a lot of repeated measures. GPAs, probably not, because 2.12, 3.37, we round GPAs typically to the hundredths position, so the chance that you have the same GPA as someone else at Shawnee, and it's probably going to happen, but there's not going to be a lot of repeated measures. The number of cars a family owns, the number of kids, number of children, those kinds of things have a lot of repeated measures. So let's say, for example, that there is a large stats class, and they took a 10-point quiz. I'll tell you what, let's keep this simple. Took a 5-point quiz, and we have the following summary. So we have scores ranging from 0 to 5. And let's say that we had 7 students get a 0, 15 students get a 1, 23 students get a 2, 29 students get a 3, 35 students get a 4, and 52 students get a 5. I want to be optimistic here and have, assuming 5 is a better score, which would make sense it would be. I want to have 52 students, okay? So this is an example of a frequency distribution. And there's a problem like this on your homework assignments, so this is the main reason I want to cover this, to show you how to handle those two problems. Now, this is equivalent to, if we do a thought box here, this is equivalent to writing out the data in extended form of 0, 0, 0. Okay, I'll stop. So 1, 2, 3, 4, 5, 6, 7 zeros. Pretend I did this 15 times. Pretend I did this 23 times. And pretend I wrote these 52 times. So I wrote 52 5s, 15 1s, 23 2s, and so on and so forth. So I would have a large data set, but instead of the redundancy of writing these things out, again, of writing 52 5s and 35 4s, we can use a frequency distribution, which is kind of a natural way to handle this, okay? And again, we have a lot of repeated measures. We don't have many scores, but the scores we do have were repeated quite a bit. So, guys, it turns out this is really easy to handle in your calculator. Let me show you how you do that. Go to Stat and go to Edit. And the first thing we want to do is we want to clear out, so go clear, enter, the information that's there. Now, we're going to need 2 lists for this. So essentially what I'm going to do is I'm going to put my 0, 1, 2, 3, 4, and 5 in list 1. And in list 2, I'm going to list the frequencies. So 0 occurred 7 times, 1 occurred 15 times, 2 occurred 23 times, 3 occurred 29 times, 4 occurred 35 times, and 5 occurred 52 times. Now, you got to think about L1 and L2 are now merged. They're now married, right? They're not getting divorced. They can't be separated. If we just look at L1 independent of L2, then 0 occurs 1 time, 1 occurs 1 time, 2 occurs 1 time, 3 occurs once, and so on and so forth. But to tell the calculator that 0 occurs 7 times, how many times this number occurs has to be found from the information of L2. Well, guys, it turns out this is really easy to do. You just go over to Calc, one variable stats, and you go L1, and your frequency list, you go second function 2, L2. So you tell the calculator where the frequency list is just by putting the list beside a frequency list. Come down, hit calculate, hit enter. You'll see the average score was 3.40. The standard deviation was 1.51. There were 161 students. Really large statistics course. That's back my days at UK, the kind of algebra courses I used to teach there. You can see that the median is 4, Q1 is 2, Q3 is 5. The range is 5, and the IQR is 3. 5 minus 2. Okay, so works out really, really, really nicely to be able to work a frequency distribution like this. Now, an application of this would be calculating your grades. Let's say, for example, that you took 5 courses. And you have an A, a B, and a D. Well, what you could do here, and let's say that these are all 3-hour courses. So we can say that our grade, we have 2 A's, 2 B's, and 1 D. Well, guys, we can't go A plus B divided by 3, but we have quality points like this. So in our calculator, guys, I'm going to show the other calculator now for those of you that don't have the same calculator operating system. So in this one, we would go into, go to Stat, Edit, clear out the old stuff. So I'm going to go 4, 3, 1, and I have 2, 2, 1. Now, to do this, I'm going to go to Stat, and I'm going to go over to Calc, and I'm going to do one variable Stat, but I don't come up like I did before where I have a frequency line. So what you have to do here is you have to hit the left parentheses, go L1, comma, L2, right parentheses. This communicates to your calculator, if you have this operating system, that you have your frequencies in L1 and I'm sorry, your scores in L1, your frequencies in L2. And you'll see that we get 3 and the standard deviation is 1.22. So your GPA would be 3.00 and your standard deviation will be 1.22. Going back to the other, if we're doing it over here, just run through it real quickly, edit, Clear out this. Clear out this. Stat, calc, one variable stats, L1, L2, and hit calculate. You guys, you get the same thing, okay? So no wackiness that goes on with R, where it calculates quartiles 8,700 different ways. The calculator is consistent. Now let's go into a future problem. Next problem just has, all right, you've got 7 numbers, 23, 32, 56, 41, 92, 85, and 20. Okay? And you want to find the standard deviation of those numbers. Stat, calc, one variable stats. We put our numbers in L1. But guys, now we don't have a frequency distribution, do we? We just have numbers like we had before. So just hit clear, calculate, and you're right back where you started from. So if you don't have frequencies in L2, then you don't put a list beside of frequencies. If you do, it'll give you, I call it well, I'm not going to tell you what I call it. All right, gang. I think, well, I don't know. I'm trying to think about what else I could, you know what I'm going to do? I want to see who is listening, who's watching these videos and who isn't. So here's what I want. This is an extra credit for everybody likes extra credit, right? So here is an extra credit assignment. Send to my email account. In the body, say Dr. Darbro. These 5 things. And I want you to do this for use these numbers right here. I want you to do this for mid-arm. So you can do it one of 2 different ways. You can download it, do a CSV, put it into R, or you can just physically type these 20 numbers into your graphing calculator. Down here, I want you to tell me your name, because sometimes, you know, like Blade Runner, Cub Lover, whatever, you know, as an email address, I may not be able to identify who it is. So if you'll do this, just Dr. Darbro or Doug or Triple D or just anything with Mr. Darbro. Tell me what the mean of mid-arm is. Tell me what the median of mid-arm of those 20 numbers. Tell me the standard deviation. Tell me the variance, and so on and so forth. So, guys, this is what I want. Extra credit assignment. To get extra credit, today is what? Today is Wednesday. I will have this uploaded by Thursday. I'll tell you what I'm going to do. I'm going to give you until Monday, June the, what is it? Let's see, today is the 3rd, right? So that would be the 8th. at 10 a.m. So if you get this to me by just send an email in the subject line, just do extra credit number 1, okay? Because you're going to have, I'm going to do this quite a bit just to see who's with me and see who's not with me, because that way, you know, that helps out when final grades are due and all that kind of crazy stuff. So, is everybody clear? Send an email to ddarbro@shawnee.edu. It helps if you spell it correctly. Say, Dear Dr. Darbro, Dear Doug, Dear whatever, anything other than Mr. Darbro will work. Tell me what the mean is, tell me the median, tell me the standard deviation, tell me the variance, tell me the IQR for mid-arm. Again, this data set is uploaded to Blackboard, or just go back and just and I'm putting it up for you. Just pause screen, right? And get your calculator out and just type those numbers in. So, gang, I think that's it. Oh no, let me show you one more thing. Seemed like there's always something else. If we did have a frequency distribution like before, let me show you how you can get a histogram and a box plot. Same thing. If you come up here to stat plot, and you wanted to do, for example, a histogram, you would select histogram, but then when you came down to frequency, you would just put L2 there as your frequency. But you know, I don't want that. I want a 1, and remember, it's not going to do that. You're going to have to hit green 1 to kick off the alpha. Okay, so you know, if you have a frequency distribution, you can get a box plot or histogram just by putting L2 in the frequency thing. Guys, I'm done. Have a great one.